Hey everyone, it's Justin again. In this lesson, we're going to be learning about the other form of circle equations, general form, and how to take a standard form equation and rewrite it in general form. By the end of this lesson, you will be able to write the equation of a circle in general form. First, we'll learn the general form equation of circles, and then we'll complete 3 example problems. So far in this unit, we've been focusing on the standard form circle equation, which looks like this. In this lesson, we're going to start examining the general form circle equation, which looks like this. Although these 2 equations might look very different, they're actually completely equivalent to each other. In order to get the general form equation of a circle, we just take the standard form equation, expand all those squared terms, simplify and combine all the like terms, set it equal to 0, and then rearrange the terms to make sure that they're in the right order. Notice that in the general form equation's left side, the x squared term comes first, then the y squared term, then the x term, and then the y term, and finally the constant last. This is always the order that these terms must be in for the equation to be considered general form. There's going to be a lot of algebraic manipulation in this lesson, so let's see what this looks like in action. In our first example problem, we need to convert the standard form equation into general form. In order to write this equation in general form, we need to expand this as much as possible. So let's start there. What is x minus 4 squared actually telling us to do in terms of operations? Since this binomial is being squared, it means we need to multiply x minus 4 times itself, which looks like x minus 4 times x minus 4. Using this as an example, what will y plus 6 squared look like? Exactly. This means y plus 6 times y plus 6. We can't expand anything else, so let's just bring down the equals 20. We can continue expanding by multiplying each pair of these binomials. Pause the video now to multiply x minus 4 times x minus 4 and y plus 6 times y plus 6. Your multiplication of x minus 4 times x minus 4 should look like this. I've chosen to use a visual or area method to multiply, but if you prefer a method like FOIL, that is okay too. You should still get these same 4 terms. Now I'm going to substitute all 4 of these terms for x minus 4 times x minus 4 back into my equation, and worry about combining my like terms in a moment. Now we can repeat this with y plus 6 times y plus 6. Your multiplication of y plus 6 times y plus 6 should look like this. And likewise, I will be bringing all 4 of these terms back into my equation. At this point, we have expanded as much as possible, but this equation is still an absolute mess. I'm going to clear out the line that we finished with to help make some space. And next, we're going to need to work on combining the like terms to simplify this thing. Pause the video here and combine your like terms. I like to color code my like terms to help me stay organized, so here are all the like terms on the left side of this equation that need to be combined. And when I combine them, my equation looks like this. Negative 4x minus 4x makes minus 8x. 6y plus 6y makes 12y, and lastly, 16 plus 36 makes 52. Since there are no other x squared or y squared terms, those terms stay as they are. And we've now simplified as much as possible. Let's clear out some more space and move on to setting the equation equal to 0. How can we get this equation to be equal to 0? That's right, we can get rid of this 20 by subtracting it from both sides. We're almost done. Let's clear out some more space here. All that's left to do is rearrange our terms a bit so that they're in the right order. As a reminder, here is the general form circle equation. To be in general form, the x squared term has to come first. In our equation, x squared does come first, so far we are on the right track. Next has to be the y squared term. Ooh, our equation does not have the y squared second. It has the x term. That means we're going to have to move the y squared term over. Pause the video now and rewrite this equation with y squared and minus 8x swapped. You should have written your equation like this. Now we have our y squared term second, so let's keep going. We need to have the x term third. Our little switch fixed this too. Perfect. Notice that it doesn't matter that this is minus 8x instead of plus 8x. The operation does not have to be addition. Next, the y term should come fourth. Yup, we have 12y here. And lastly, the constant term should be at the end of this part of the expression. And yes, we have 32 here. We have successfully rearranged our terms, so this is our final answer for the general form equation of this circle. This problem tells us to write the equation of the graphed circle in general form, and we have a circle on a graph. Now, we cannot just go straight from a graphed circle to writing its equation in general form. Instead, we're going to have to write the equation in standard form using the center and radius first. Then we can go through all of the algebraic work to convert it into general form. Pause the video here and write the equation of this circle in standard form. The center of this circle is at 3, 1, so that means I can fill in h and k in my standard form equation. Luckily, if I move directly to the right of the center, the point on the circle falls on a whole number point, so I could just count and see that the radius is 4 units. You could also get the radius by moving up, left, or down from the center instead of right. To put that radius into my equation as r squared, that would be 16. Now we have a standard form equation, so it's time to convert it into general form. I'll also get rid of this graph to give us some more room to work with. As a reminder, to convert to general form, we're going to need to expand, simplify, set it equal to 0, and then rearrange the terms. We'll start by expanding the equation. Pause the video here and expand this equation as much as possible. First, I can write out the multiplication that my exponents are implying. Next, I can multiply both pairs of binomials. X minus 3 times x minus 3 gives me this. And y minus 1 times y minus 1 gives me this. I've chosen to write these terms as minus 1y, but if you left the 1 out and just wrote them as minus y, that is totally fine too. There's nothing to do with 16, so I just brought it down. After expanding, I need to start simplifying by bringing all of the like terms together. Let me clear up our workspace a bit, and you can pause the video here and combine your like terms. I can combine my x terms to get minus 6x, my y terms to get minus 2x, and my constants to get just plus 10. So what should I do next? That's right, it's time to get this equation equal to 0. Pause the video and do that now. I can get this equation equal to 0 by subtracting 16 from both sides. Is this a good final answer for the general form equation of a circle? Nope, we're not quite there. We just need to rearrange our terms to make it match the general form equation. Pause the video now and rearrange your terms so that they're in the proper order. You should have swapped your y squared term and x term to get this. Again, I don't have to worry that I have a lot of subtraction in this equation instead of addition. The general form equation is all about the order of the terms, not their signs. All right, let's do one last example together. This problem says to write the general form equation of a circle with a center at 0, 0 and a radius of 6. How should we start? You got it. First, we need to write the standard form equation. So what does that look like? Since both h and k of the center are 0, that just looks like x squared plus y squared. And since r is 6, r squared is 36. There's not actually anything here for me to expand or simplify. Can I set it equal to 0? Yes, I can do that by subtracting 36 from both sides. Next up is rearranging the terms to match standard form. Oh, that's weird. We only have 3 terms here, not 5. Any ideas? Well, anytime one of your center coordinates is 0, it will make either A or B in the general form equation 0. In this case, with the center at the origin, they're both 0. So when we're checking the order of our terms, we can just skip over x and y. And 6x squared comes first, followed by y squared with the constant last. This is 100% correct. Now you can write the equation of a circle in general form. If you don't have an equation to start with, you'll need to write an equation in standard form before you can begin converting to general form. Once you have a standard form equation, all that's left is to use algebra to manipulate it into the right form. You'll need to expand the terms as much as possible, combine any like terms, get your equation equal to 0, and then rearrange the terms to match the general form equation. Good luck on your practice, and I'll see you next time. Hey.